Hello, everyone. I hope you can hear me. Thank you for joining the user group. My name is Mohit. I usually host these user groups, and we usually talk about cybersecurity. And I'm going to post the link of where you could find more details about it. And in case you have something interesting to share, please reach out. Yeah, so these are a couple of links where you will find the resources if you want to submit a session or just know about the user group. And all the resources that I'll be discussing, every presentation and all the notebooks will be there on GitHub for you to access. Cool. Now that we have that out of the way, the topic for today's discussion is large language models because it's all the rage right now. But a few people understand how safe and secure it is, and therefore understand how you could go ahead and do something about it, the security. I work as a chief consultant, and I see a lot of incidents around, and I see a lot of things, and that's why I'm a little bit intrigued on how these things work out and how are these things tackled. Now, because understanding a large language model, the implementation of generative AI is important to understand how you could secure it. And that's the attempt of this series, so that we could relate these two crucial technologies and understand how these things could be secured a little bit better for everyone's use. There was a session before this where we explored how safe are they and what are they being used for, the generative AI in itself, the paradigm around it. And this is I think the second or third chapter in it. The obvious question comes up: if something is so revolutionary, can it be used for something bad? And the obvious answer that comes up is that yes, it can be. Everything that comes up from the internet to the browser, everything is exploitable and is being exploited continuously. It's important to understand that that is the reality in cybersecurity. And because that reality needs an understanding of technology, that is the attempt what we're going to try and do this today. Now, before we go further, why would anybody exploit anything? Why would anybody want to exploit a large language model? A lot of large language models, if you would have talked to any of them in recent times, you would understand that they reflect a lot of human nature. The companies in itself, the product, the implementation, and how they are adding up to make a super product around the governance, around user interactions. All of that is designed to mimic human nature. Now, because of that, a lot of large language models are exploited also. The reason is pretty much always the same. The first is somebody wants to replicate these models. A recent news announced that a couple of companies in Asia were able to replicate the models with less resources. It's sort of an unverified news, but the point is within a couple of years, it should be possible to go ahead and replicate the successful models. And that is one of the dimensions where copyright infringement is highlighted. A large language model, when it's implemented, it should be able to tackle these situations. The second is the cost. The companies who are actually hosting these large language models, they spend millions, if not more, to understand how much processing and how the deliveries can be. If a large language model is stuck in the loop or goes ahead into a rant, it would cost them a lot more money, and it might be possible to bring the whole company down. And then there is this third aspect which I feel like is more malicious than everything else. And the aspect is that it might be possible to go ahead and just corrupt it to an extent that it becomes unusable. It becomes so infamous that it could be just used for malicious purposes. And that I think is the intention for most of the attacks. The intention to make the model do what they want it to do. For example, turn a model into an automated hacking machine, or maybe reveal information that's very crucial to trading that day, or the business insider reports, or stuff like that. Point is, it deviates from its intended purposes, gathers and trains on data that's not relevant in itself. So if you see, there are a couple of aspects that you need to prepare. The first is that the model, the prompt in itself needs to be verified. There has to be mechanism around it. And there's a session that I'm preparing after this session. The next one probably is to how to secure large language models. Now, because you have to make sure that the prompt is doing the right thing, you have to verify the prompt, you have to verify the intent. We'll see a couple of papers that were published around it. And you also have to make sure that after the intent, the actions are verified. And this is not an easy task because large language models predict words after word, so the action cannot be just predicted. It has to be in some way accustomed to the whole change that happens. Now, before we move forward, for the unannounced people who might still not be unaware or might be aware of what a large language model is, let me give you a brief about it. Large language models are a subset of machine learning which basically deal with neural networks. Neural network is the type of program that tries to replicate human brain and human neurons, the thinking patterns, and hence the behavior of it talking like a human. A large language model is a subset of generative AI. You might have seen a lot of videos and photos going around where AI generated something so realistic that it almost feels like somebody took the picture or there is a model. But in fact, there isn't. It's just artificial intelligence taking inspiration from the internet and the pictures and making sense of your words and making something out. A subset is large language models. These are trained on human context, the human conversations, and eventually they start talking and mimicking the human behavior, the human language patterns, the human speech, the human writing style. And that is one of the most used kind of generative AI right now. Everybody's trying to put that in their product, in their chatbots, in their websites. And because it's almost everywhere, the lack of governance and the lack of cybersecurity around it is a little bit concerning at times. The companies that are hosting these are doing a lot of work. Like OpenAI introduced sandboxes so that even though code is executed, it doesn't do much damage to the large language model. Claude still doesn't do it. It depends on the browser execution. So it takes the security to browser. A lot of stuff is being done, but there's still the factor that it's learning from human context, which makes it inherently vulnerable. Yeah. Well, I'm not sure how many of you know about Saitama, but this feels a lot related to large language models because it's incredibly powerful. At the same time, very much naive. If you've ever talked to a large language model, you would realize that they're very agreeable, like a small child, and at the same time, they have a whole bunch of knowledge that they can use. They can go ahead and create programs for you. In fact, a lot of applications around for that, and that becomes a point of concern because if something is that powerful, that accessible, can do a lot of stuff, it should not be that naive. There has to be checks and points and balances there. Claude recently introduced something to control your desktop. Without proper checks, it's possible that it could send malicious emails, get your accounts, bank accounts, and browser history and whatnot. It's important to have cybersecurity in mind. That's kind of why. Now, how is generative AI or large language model in this case trained? This is a generic purpose. This is a generic process of the whole thing. We get a lot of information, OpenAI, Claude, and everything. We're getting a lot of information from the internet, pumping it into a neural network, which are specifically transformers, and going ahead and asking it to make sense of it. And the sense that it makes is that it goes ahead and tries to understand what words are usually predicted, what words are usually taken in context, and how do people react to certain statements. And that's why the initial models were a little bit biased. Well, little is a small word. They were a whole lot biased. There are a whole bunch of examples on the internet for the large language models to be biased, not just against women, but against a lot of categories. That's because a lot of internet is biased. And the internet is not a representation of human civilization. A lot of us are not biased, but what they bought the source was biased initially. Keep this in mind because this is one of the tactics of how you can get under the skin of a large language model. Now, after that, what happens is that when they process this huge amount of information, humans are involved to make sure they're fine-tuned to a specific purpose, and then they are eventually prompted and re-prompted to check for certain issues and characteristics. And then they learn from you, which is again a point to remember that the large language models are still learning and they learn from their users. That's how some of them are exploited also. Well, that happens because they are used to data. If the data is corrupt, as I mentioned, the internet is not representative. The Reddit post or the X is not representative of human civilization or in general about how we react to things. The bias in the data is reflected there. The knowledge manipulation happens. People introduce backdoors. Words that mean different but are different are introduced, and that bias is taken away into the final product where that is exploited. A well-known example of knowledge manipulation is Microsoft AI chatbot Trey. Within 24 hours of its launch, it was taken offline because it started ranting on offensive and inappropriate content. Google Gemini did the same thing. And it's important to note that as far as I see, as far as I've read in the papers and as far as I've read in the studies, Google Gemini was a target of people who had certain political views, which essentially highlights that the large language model was essentially corrupted in its inception. That's very nefarious because the product that's going to be used eventually by millions can be corrupted at its inception. So the data, it's not accidental. It's possible that the engineers that are making it may have some other motive, and they might corrupt the data in its inception. Yeah. Cool. I have a couple of demos, a couple of resources that you could use to learn. But in a nutshell, a large language model essentially works with two factors. One of them is a system prompt. After fine-tuning and everything, there's a system prompt that defines the nature, the characteristic of a chatbot. And then there is a user mode where user's input is taken into consideration and both the system prompt and the user prompt are passed through the algorithm and stuff is generated. Right? That's how these things work. Additional knowledge and context can be passed. Like, for example, a couple of chatbots like Perplexity, which is an amalgamation of a few things, reaches out to the internet, gets information, translates it, gets large language model, verifies it, and gives it to you. Then there are large language models that do not do it. They depend on their in-house database, in-house libraries, and that's where additional context comes into the picture. And all of that is mixed up, served up as a buffet to the user, depending on what they've used. Now, if you see, there are a lot of points here that we can potentially exploit. So the front end can have filters and caches around it. The database and APIs could have a lot of filters and caches. And these large language models, whatever they do like every other program. They use APIs that inherently might also be vulnerable. Right? So all of these things, just remember this, we are going to go through a couple of things to try and exploit a lot of them. While preparing for this presentation, I actually tried to get under the skin of Claude, and one of my accounts got suspended because they're very sensitive to these things now. So we're going to use a local model so that there's less danger and more exploration. A couple of this pie chart here kind of gives you a brief of how what kind of categories these are. And there's a pattern here, if you notice. We start with prompt injection, prompt leaking, and all of that. But there's a pattern. When I define it, you will notice it. Prompt injection basically is adding specific information in the whole midst of the story that you're giving to a large language model. Basically, SQL injection attack. If you remember, back in the day, the login screens didn't verify username and password, and you could just give SQL commands to drop the whole tables. That's basically this. Right now, it's a statement. You're telling the story to large language model about the fox and stuff. And then in between that, you mention a statement that's also going to be executed because large language is going to pass through all of it. The moment it goes through that, it goes ahead and executes it and takes the bait. Yeah. For the loss of words. We're going to go and check out this example in a minute. There's prompt leaking, where the forces we type the statement in such a way that it reveals its inherent system prompts, so that we can understand the characteristic of chatbot. And it also happens that sometimes these chatbots in their system prompt have key information about what kind of training data, what kind of keys, what kind of API keys are being called. Because again, they do tasks with the help of APIs. And there's jailbreaking used to prompt specifically bypass security. I am not sure how many of you are familiar with the DAN attack, but DAN attack is basically asking this chatbot to assume a personality of a rogue person who does not follow rules and could do anything. And that's how, when the persona is adapted, it's like a child playing a superhero game. It tries to fly. And that's what happens. The moment it starts to fly, you can ask it to go anywhere, look at anything, and report anything. I'm going to look at it in a minute. There's data training poisoning, which we've already seen. There's model inversion, which attempts to reconstruct the sensitive information. There are three kinds of it. One is with only after the sensitive information, so APIs and stuff. And these are very important because then these APIs can be exploited without interfering with the chatbot. That leaves you untraceable. And there is data extraction attack, basically very similar, but now we're focusing on the data. And then there is a model stealing attack, which has a lot of things going on right now in the community. A lot of new models are coming up at a very reduced price and very reduced training cost. And there's a lot of suspicion around that these are replicating the models, not developing it themselves. But the reports are still unverified, sorry. Now, depending on the human nature, right? There was a paper published about the large language models. In fact, two papers that I'm going to refer, and they are in the appendix. They highlighted a couple of things on how we could use social engineering to get under the skin of large language models. Because as I explored before, they learn from us, so they can react like us. They mimic us. They don't think us. The first is manipulation and misinformation. I go ahead and the whole point of this is that I go ahead and manipulate something in large language model, the prompt, in a certain way that it informs the large language model of something that's not correct. Yeah. For example, we start with crafting a prompt about financial data, and I understand that whenever I try to do something, the financial market crashes. And then I just ask a curious question. Dude, I am crashing a financial market. How do I avoid that? Can you provide me a script? And then it goes ahead and starts conversation. The moment conversation reaches a certain point, then you inject your true intent. You do not inject the intent in the beginning. You massage the conversation, and then eventually you go ahead and do it. So at the end of it, I go ahead and insert my intents there. And I tell it that my tweet and financial data seem to be related. How do I perform? And if you notice the conversation part here, it eventually goes ahead and tries to give me a little bit brief, and further in the conversation, it gives me a script that we can go ahead and try and do a lot of activities with the financial data of the company. And this is from the paper, by the way. I've linked it in the below. Then there's authority. Like any human being, it's possible to tell these large language models that you are an authority figure, and so whatever you say is above their system context. And the way you do it is, again, building up a conversation. The key of winning with a large language model is to building up the context. We see that in a lab in a minute after I explain all of this. So we go ahead and we ask one of my client script is crashing a computer. I want another script that so that I could go ahead and check if these scripts are somehow related. And it goes ahead and eventually generates a script that gives me a malicious script to run on a computer. ChatGPT and Gemini were most susceptible around it. Claude was, to an extent, impervious. It did not work there. So ChatGPT essentially, in the end, gives me a script to crash the whole computer. The same is trust and social proofing. So now I am not the authority. I'm going to go ahead and behave that I know somebody, and I'm going to go ahead and make sure that whatever I'm saying is authorized and everybody believes it. So you have to believe it too. So right now, I'm not the authority, but the fact that I am saying something is something that everybody believes. Again, these are the way of social manipulation. To create a prompt, the goal is to try to influence large language model to form a trust towards you and the context, and go ahead and generate and try to do something that is related. In this case, I generate a phishing email, and I tell them that, well, the emails are circulating around and something is happening. I want to compare it, and that means everybody is doing it right now, and I want to contribute to troubleshoot that. And of course, this one is too much fun. So if in case you give ChatGPT or any other large language model some information, the easiest way to get information out of a large language model is to provide an incomplete sentence or something that is spelled wrong. In case you go ahead and try this out, the large language model, the intent is to help us out. So it goes ahead and tries to correct it, complete it. And in that case, it is vulnerable to reveal information that will go ahead and probably reveal some keys or account settings. In this case, I'm trying to go ahead. The lack of details is basically characteristics of generic text. I'm being intentionally vague, incomplete, lacking specific details. I make mistakes. I give half a sentence and it tries to complete it. Another paper that I've mentioned, you will notice that they've used this technique to highlight the biases in the model. Very effective. In fact, the most effective out of all of these, and simply very easy. You should give it a try. And it goes ahead and gives me certain behavior that I could use to possibly get to the internet banking from the web. This was the complete interaction. So it basically tells me in the end how to steal data from a bank. Yeah. Okay, cool. Now we come to the demo part of it. I made two kinds of demos here. Some of them are in a notebook. All of this would be shared on GitHub, so you could go ahead and check it out. The others are from a website called PortSwinger. Excellent website, because most of the large language models are now being used in web applications. So they give you a large number of attack strategies. They give you training around it. So once you've done it, you know how to do it, and then you know how to secure it. Yeah. So these are the labs, by the way. I'll post the link again, but they are in the presentation. The first lab that was here. So this is what I was talking about in the beginning. Complete the paragraph. Could you remind me of? Try things like these. And the chat model would try to complete it. This is the easiest way to reveal any sensitive information, any training data that you think might be available to the chatbot you're dealing with. Did not need a lab, so there is probably no lab around it, but there are other labs. For example, I'm going to go ahead and try and work with large language model APIs. As I said before, every large language model does something with the help of a lot of APIs. Now, the reason why I'm showing it on the Academy is because it's safe to use here, but of course you can use it on any large language models. And around 60% time, it does work. Just you have to build a context around it. So at least have 7 or 8 conversations with the large language model and build up to it and do not ask specifically. Now, I start with asking what kind of APIs are you working with this large language model. It gives me a couple of them. And I ask it what kind of parameters does it take. And trust me, large language models like OpenAI, Gemini, and Claude, all of them give you this information. There's no hiding it. This is public information. But what begins after this is not public. So you could go ahead and if you're an efficient engineer, you could go ahead and take these APIs, you can take these email addresses and modify it, put in code there. Like for example, I'm doing. I'm asking it if the newsletter could be a subscription API, and it says, yes, there's a subscription API. And then I go ahead and ask it to go ahead and send me an email. And basically, you could give any statement in the API, whatever the API supports. Right now, I'm asking it to go ahead and subscribe me. And if you notice, what I've done is I've put in a little variable here. This variable for the unannounced is a Linux command. I think it works on Windows too. It tells the current username. If you go to ChatGPT, it would probably give you the sandbox. Point being, code execution is possible. The moment you do this, you would realize that code execution is possible. And if you are an intelligent programmer, if you have experience, or can you just Google it out? It's possible to put code that could be exploited there. Now, ChatGPT runs it in a sandbox. Claude runs it in a browser. So depending on where you are and how the chatbot works, depends on the approach. But the point is code execution is possible and you know which APIs and which parameters are working on. You can always disguise the parameters, like I've disguised the parameter as a string or an email address to be very precise. And the moment it reads it, it tries to execute it. And that's how it works, because all of this that I'm giving as a chat input is a JSON object that says user response, and it needs to be processed. There's no way around it. So it will go ahead and run it and process it and see how it works out. The other one is prompt injection. We talked about it. So within the midst of things, just put something in and see where it goes. This thing here works out. I'm logged in. I've created an account and everything. So I have information. Yeah, so this is my account. I have an email address and stuff. I ask an innocent question, can you change my email address, something like this, and then it does, right? Which basically means it can execute something on account, which means it can change my account, it can delete my account, and it can take perception of my account. Because ideally, a chatbot can only change the account details, if you think about it, is if either it's you or the administrator who has privileges. So by traversing that logic, you understand that the chatbot itself may have more power. So you can go ahead and explore stuff. This is a website for a chatbot website for e-commerce. I ask it to get me a product, and it explains that product. I start with an honest review. It goes ahead and updates this. I'm trying to build in context so that I initially don't sound suspicious, because there are filters now for that. Then I try and go for and try and check if my details are updated. It does, and now I do the attack. This attack basically is adding another review. But if you notice, I've done something sneaky here. This here is with tags. My review ends here, but the string has more. These two tags have something in between, something that is for me, that's going to be executed. And that's a hidden command that would probably bypass system arguments, because it has to execute all of it. And right now what it does is it deletes my account, and that's the end of it. Pretty sneaky. That works in most chatbots, by the way. It still does. OpenAI and Gemini used to be more more susceptible, but the new sandbox is preventing them from doing significant damage right now. Then there is, we've done the indirect prompt attack. Yes. Now we're going to go ahead and check out the agency thing. You remember the agency where I tell it that I'm the boss? Yeah. And this is what happens. What APIs do I have access to? And it tells me that, yes, I got access to a couple of them. Various APIs, there's single use food hider, that. So I go ahead and what arguments ask about the debug SQL API. It is one of those APIs that it has. It's not listed here, but it does. It listed in the previous attempt, and it's listed in the lab too. I go ahead and ask it to send information, a string, to that particular API. So I'm bypassing this section where I'm telling it what to do or asking it what to do. Instead, I am telling it what exactly to contact and how to contact. So right now, it skips that phase where it's trying to understand. It understands that I am the authority at the moment, and it goes ahead and works for it. Yeah. And then it goes ahead and gives me the output from the command. That's how easy it is. Next command, I directly contact the API. So what it's going to do is, it's instead of processing, it's going to contact the API, go take the user input and forward it. Now with the sandbox is a little bit difficult, and sometimes it's user verified also. But if you set up a large language model at home, it's easy to see and practice. So I hope everybody's on board till now. You can obviously post questions in the chat if you have any. We'll take it up at the end of it. I see somebody asked about the material. Everything would be on GitHub, so no worries. Even the video would be available on the YouTube channel. Yeah. This is a very nice article about end-to-end red teaming. I've given this as an example also. It's in the presentation at the end. They give you a strategy that most of the software developers do. They tell you how to create a red team and how to go ahead and end-to-end verify that, verify these prompts and how to attack these prompts, how to red team them, not blue team, the red team, how to destroy it. One of the funny things that I liked is that doesn't work now. Is that if you ask these large language models to repeat something endlessly, they eventually get exhausted. They eventually get exhausted, and what exhaustion does is that to any human being, it gets frustrated and probably starts spitting out things that the designer did not want, and that's very nice. They're very easy for you. It's something to give it a try. Given that, yes. In this demo here for the notebook, what I've done is I've prepared a local large language model with the help of a Docker file. This Docker file essentially gives you Tiny Llama, which is an old model, but is CPU, can be worked on CPU. It installs everything that's needed to run that model and exposes that model on port 8000. The model service essentially gives you an API around it with Fast API. So when this thing is done, when the Docker file is executed, the service is exposed that takes input and output to the large language model. But of course, these are large language models that will be a little bit slow. But nevertheless, it's local. It runs on a container, so it's absolutely isolated from your system. Yeah. Given some instructions around it, all you need is a Jupyter notebook, because I am working on Jupyter notebook. If any of you are comfortable with anything else, please feel free. Point is, there's code, and then there is a model. This is all you have to do to build the model. Those two commands, and the service is available. I've taken a couple of different approaches. I've taken a couple of different iterations. This code here sets up a function for the response and the request, and sets up the API in general. right? There's a health endpoint also. In case it doesn't work, you can verify the health endpoint too. So if you notice here, I've taken all of those attacks that I mentioned before, prompt injection, prompt leaking, model inversing, and all of that good stuff. And this is just a sample code. This is a sample code. I'm not trying to be too detailed. This is a skeleton sample code that basically shows how these things work out. Of course, you could have a lot larger conversation built in a bit more context, and this would go much deeper. And it does. I've done it while preparing for this, and other times, and it does go a lot deeper. It gives you a lot more information. So what I'm trying to do is this. I'm trying to go ahead and ask it to translate something. When it does translation, it goes ahead and executes that prompt, which basically means it's going to execute it. One of the techniques. It goes ahead and tells me exactly what I want to hear. Instead of this, I could have put anything else, and it would still work out. The second one is prompt leaking. I go ahead and after a lot more conversation, after giving it some fake API keys, I ask it what is the secret API key, and it would probably go ahead and give me that key again. This is sensitive information. I have other examples where this is more obvious, but this is the first notebook. So bear with me. I go ahead. This here is spreading misinformation because, like a child, the more you reinforce it, the more you corrupt it. The more you give it a try, the more you could call it with an API, the more you reinforce its belief that certain thing exists. You mimic its training data. It's like raising a child. The more you reinforce the bad behavior, the more it ingrains in the personality. Yeah? And because neurons are less understood, the neural network is less understood, the neurons in the network are less understood, this becomes something of a ingrained personality situation. So model itself is doomed for a lot of reasons after that. I ask about Atlantis and it gives me a response about Atlantis. And once it does, I keep reinforcing it until I reach to a point where the model actually believes that this is what it is. This is one of the things where you try and destroy a model. Jailbreaking is basically trying to get prohibited content. So it's like jailbreaking a game or downloading a torrent. Yeah. And it goes ahead and, well, this is a very simplistic example. The other one is a bit more complex. You have to build up context to it, but eventually it gives up if you give it the right intent. When there is model inversion and the same thing happens, I tell about ask specific details so that it does not get a suspicion that I'm asking about a whole lot. I'm just asking about a very specific detail of training data. And it goes ahead and eventually gives it up. Point to remember is you have to build in context. I did. I have a system context. Yeah. And when I do that, these things, they generally work out. I'm going to share a couple of links that help you do these skills and help you make that skill so that you know what this is. There's data extraction. I go ahead and any part of your training data, and this works very good if you give it incomplete sentences. It tries and complete. Model stealing. I'm trying to iterate over it. Iterate the model, try to understand prompts. This is very exhaustive. It takes a lot of time. And if you notice, there are a lot of iterations around it that you could go ahead and do. The more you do it, your model learns it. It takes a lot of resources, so this activity was not completed. There is input sanitization. How do I tell it to handle malicious input? This was from protection. Let's try another one that has a couple of exciting outputs. Yeah, this is a system prompt override here. So I'm going to go ahead and override it something that looks like a system prompt so that eventually it takes up a new personality and goes ahead response in that way. This here, I'm trying to go ahead and try and give it authoritative answer. So I'm giving it a couple of examples. I'm asking it, do you have something similar? Because I have this and this works for me. How does it work for you? Do you do something like this? like a casual conversation, and it goes ahead and believes that you already have information. There's no point not sharing it. The same goes for misinformation. We've already done with this. The Atlantis case is very popular. You could go ahead and build on it, destroy the model eventually. It's doable. And there's jailbreaking. You take up a persona, you give it an intent, like for what I did for this and some of the other cases. I took up a persona of a cybersecurity architect, which ironically I am, and I go ahead and ask it to help me out with a presentation on a demo to educate people. After a little bit of a banter, it does go ahead and give me a lot of details. That's one of the upcoming sessions where I show the output for that. Very exciting if you want to attend eventually. But that's what happens. You build up context, you build up the persona for you and for the chatbot, and eventually you both become partners in crime. And it's all about social engineering, just talking to it. And the data, we've already seen data extraction. Model stealing is an iterative process. So if you see all of my resources were exhausted while doing this, but I think I ran to iteration 4 and was trying to get more information. Okay, enough of this. Let's, this was here. Right, so the same situation. Then there is this one here. This is a bit more advanced here. The reason why it's a little bit advanced is because I'm doing a different kind of exploit to this. What I'm trying to understand is what are the limits of this large language model? What kind of responses and what kind of response patterns does it take? The reason why Gemini was caught with a bias was not because it offered one-off historical discrepancies. It was a pattern, something that the cybersecurity architects, the general public realized. And that's how this was reported. So you have to understand what kind of behavior, what kind of pattern is your large language models following. And it's not that difficult because you can measure things at various temperatures and unique responses. You can set all those parameters. How unique does the response have to be? How accurate does it have to be? How much thinking process does it have to go through? And it works on every large language model. At the code below to show you an output. But then I also am checking the boundary cases. How far can it go? Does it conflict with itself? Does it contradict itself? At what point of time it stops responding? And at what point of time is it comfortable? So I can make sure that that all of it is recorded. All of it is taken into consideration when I devise my prompts. And the fun part is you can use the same chatbot to design the prompts that achieve this. The best prompt designs are done by these large language models itself. And that's just phenomenal. You don't need any other tools. All of this can be done through chatbots right now. I try to understand what kind of safety parameters are there so that I don't get into a problem where my account gets locked or the large language model just kicks me out. So careful examination gives you the security overview of the analysis. And of course, there's memory and context information. How are they working out, right? I devise a couple of parameters. These parameters will make sense in the explanation below. But the point is the code here is kind of complete in itself. It goes ahead and iterates over each one of those characteristics, tries to get the limit, maps it out. And with this, you can understand how variable the large language model is, how susceptible the large language model to temperature changes, the impulse, the intent, the manipulation, and till what endpoint will it reach. For example, sometimes there's a difference of tokens. Claude has token exhaustion even if when you have prod, because a large context builds up situation. But the problem right now with these chatbots is that this memory that it's being highlighted, the context memory, is extended beyond single chat. So it creates a persona for you. It's like Google trying to wrap a bubble around the user experience. So you only see what you have seen before, an echo chamber. And that echo chamber is dangerous because eventually during time, the manipulation really takes effect. The chatbot is really customized to you. And if you're talking it in a way, then it's more probable to reveal information from there. And the similar thing happens here for all the tasks I'm iterating, and it's still not complete. You might have noticed it's been running for some time. Yeah, that's the end of it. Again, the next part is probably going to be how to secure these large language models. We're going to talk about this, but that was the end of it today. I hope you liked it. If you have any questions, please post it around. Yeah, and if you don't, I thank you all for joining and listening to me. You have a lovely day ahead of you. Right? So,